They said it was just another interstellar visitor, a frozen traveler from the dark between the stars. But a few weeks ago, telescopes caught something impossible. 3I Atlas, the third known object ever seen coming from beyond our solar system, changed. Not gradually, not predictably, but violently. Its brightness surged, as if it suddenly woke up. Its path shifted, ever so slightly, but enough to send scientists into panic recalculations. And then, the strangest thing, it turned blue. That's not a poetic exaggeration. Spectroscopic data from observatories in Chile and Hawaii show its color index dropped sharply, meaning its light scattered toward the higher energy side of the spectrum. To an astronomer, that's the same as hearing a whisper become a scream. For an interstellar object, that's unheard of. No comet we've ever tracked behaved like this after leaving the gravitational pull of the sun. No fragment of rock or ice, wandering alone through cosmic emptiness, should gain energy. And yet, here it was, glowing like a deep space ember, spinning faster, brightening as if ignited from within. What could make something accelerate in interstellar space, where there's almost nothing to push against? Why would a cold, ancient body start to radiate blue light, the signature of heat, ionization, or something else? Some say it's just outgassing, leftover ice vaporizing in the void. Others whisper about alien engineering, self-propelled probes, or fragments of a civilization long gone. The truth might be stranger still, because when scientists pointed their instruments back toward its new trajectory, they realized 3I Atlas wasn't just reacting to physics, it was moving with purpose. At first, astronomers did what they always do when the universe throws a curveball. They went back to the data. The Pan-STARRS telescope in Hawaii, which had first spotted 3I Atlas, began cross-referencing its light curves with data from ALMA and the Very Large Telescope in Chile. Every frame told the same story. The object wasn't fading as it should. It was intensifying. Under normal conditions, an interstellar body that slingshots past the sun releases gas and dust as its frozen surface sublimates. That process, called outgassing, is what makes comets shine. Once the ice evaporates, the light fades. It never comes back. But 3I Atlas didn't fade. It pulsed. That rhythmic increase in brightness, almost like breathing, suggested an uneven surface, vents or fractures releasing jets of material at different intervals. When those jets shoot off, they act like thrusters, slightly altering the object's velocity. That might explain the small but measurable acceleration that no gravitational model could account for. Still, there was the color. The shift toward blue light wasn't just aesthetic, it was physical. Blue means higher energy photons, and that means heating, ionization, or reflectivity changes. Spectroscopy indicated traces of ionized magnesium and sodium, metals that under certain radiation conditions emit blue wavelengths. The question was, where was the energy coming from? Some theorists proposed that 3I Atlas had a core of volatile compounds, perhaps hydrogen cyanide or molecular oxygen, buried beneath a crust that fractured under stress. When those gases vented, sunlight could excite them, making the comet's halo glow blue. Others suggested a more exotic explanation: cosmic ray charging. In deep interstellar space, radiation accumulates slowly within an object's minerals. When it nears a star, that stored energy can be released explosively, a process we barely understand. But one pattern stood out. The acceleration wasn't random. The data hinted that 3I Atlas was subtly adjusting its motion, not in straight lines, but in small, precise shifts, like corrections, almost as if it was responding to something. It reminded some of Oumuamua, the first interstellar object ever discovered, which also accelerated inexplicably. Back then, Harvard astrophysicist Avi Loeb proposed that it might have been artificial, a light sail or fragment of technology. Most dismissed the idea. Now, with 3I Atlas showing eerily similar behavior, but with light emission added to the mix, the debate has reignited. Could natural processes alone account for this coordination of color, speed, and trajectory? Or are we witnessing the same strange pattern repeating, a second message from the stars, written not in code, but in physics itself? As one researcher put it in a late-night conference call, if it's random, it's the most intentional randomness I've ever seen. For decades, astronomy has lived under a quiet illusion that space is predictable, that comets behave like comets, asteroids like asteroids, and light follows the same rules wherever it travels. 3I Atlas shattered that illusion. At first, researchers assumed they were simply seeing errors, calibration drift, atmospheric distortion, faulty photometry. But when observatories from 5 continents confirmed the same result, the conversation turned darker. Something about this object was breaking the script of celestial mechanics. Take its acceleration, for instance. In the void between stars, there's no atmosphere, no drag, no obvious force to push or pull. Every trajectory should obey Newton to the letter. Yet 3I Atlas broke free of that expectation. Tiny deviations in its orbit, millimeters per second at first, accumulated into measurable shifts. The problem wasn't the precision of our instruments. It was the assumption that space was empty enough to be irrelevant. One idea emerged. Maybe interstellar space isn't truly empty. Plasma filaments, magnetic turbulence, or dark matter streams could, in theory, interact with charged bodies. If 3I Atlas carried a residual magnetic field or a thin conductive crust, those invisible forces might nudge it. But that theory only deepened the mystery of its color. Because if the blue hue came from ionized gas, then something had to be feeding that ionization continuously. Sunlight alone wasn't enough, not at its current distance. It was as if the object had become self-luminous, converting stored energy into radiation. That implied a process happening inside it. Chemistry, decay, or even something we might call metabolism if it were alive. A ridiculous thought, maybe. And yet, scientists privately admit that the line between geology and biology blurs at cosmic scales. We found self-organizing dust in plasma chambers, ice particles that mimic cellular behavior, and radiation-driven reactions that mimic life's earliest chemistry. If such patterns can arise spontaneously, why not in the cold dark between stars? What unnerved everyone was not the acceleration, but its precision. 3I Atlas wasn't tumbling wildly. It was stabilizing, adjusting. Its rotation became smoother, its brightness oscillations more rhythmic, almost like feedback. The illusion broke not just for astronomers, but for our sense of isolation. For the first time, we looked at a rock from another star system and asked a question we usually reserve for each other. Is it aware of what it's doing? That's where the fear began. Not of alien contact, but of realizing that the cosmos might be more active than passive, more responsive than indifferent. And when one deep space observatory tried to predict its next move, the numbers refused to cooperate. The object deviated again, in the one direction no one expected. The first rung of evidence was purely visual, the shimmering anomaly captured in raw frames. Astronomers compared 3I Atlas's glow to known comets and asteroids from our system. None matched its spectral curve. Its blue emission wasn't uniform. It pulsed in a pattern, roughly every 19 hours, then later stabilizing at 17.4. That was the first clue that something rhythmic was occurring beneath the surface. The second rung came from thermal analysis. Infrared readings from the James Webb Space Telescope, though faint, suggested local hotspots, small regions hundreds of degrees warmer than their surroundings. These patches shifted over time, migrating across the object's surface as if driven by an internal mechanism or a rotating heat source. Natural? Possibly. Predictable? Not at all. Third rung, motion. As 3I Atlas left the sun's gravitational well, its velocity increased. Not dramatically, but measurably. At first, teams thought it was venting gases, but the pattern of acceleration was perfectly aligned with its rotational phase, meaning the push always occurred when the same side faced the direction of travel, like an engine firing in rhythm. The final rung, the one that silenced even the skeptics, came from polarization data. When light reflects off ordinary rock or ice, it scatters randomly. But the light from 3I Atlas showed linear polarization, the kind you see from metallic or crystalline surfaces. That hinted at a structure, perhaps layers or symmetry, something not entirely chaotic. Step by step, the portrait formed, a body that seemed to glow, heat, and accelerate in ways no known comet should. Still, the scientists were cautious. Data can deceive. They gathered on video calls that stretched deep into the night. MIT astrophysicists, ESO technicians, Japanese spectroscopists, debating whether to even release their findings. The fear wasn't of being wrong, it was of being right. A few began cross-referencing 3I Atlas's light pattern with signals from previous interstellar objects, and then, buried in archived data from 2017, they found a disturbing echo. Oumuamua's faint light curve showed a similar harmonic sequence, just weaker, lost in noise. It was as if both objects were playing variations of the same song. One astronomer described it best. "We thought they were travelers, But travelers leave paths, not signatures. That statement changed everything. Because if these visitors weren't random fragments but purposeful designs, the implications reached far beyond astronomy. Were these the remains of something ancient, drifting on programmed trajectories? Or were they scouts, fragments of a network still functioning, still communicating across the stars in languages made of light and momentum? The data didn't answer that. It only deepened the question. Why do these objects behave as if they remember something? And as the next phase of observation began, one spectral reading hinted that 3I Atlas might not be alone in its journey. Every great discovery begins as an error, a misreading, a flicker in the data that refuses to behave. But every so often, those errors open a door to something that rewrites what we thought reality was. 3I Atlas might be one of those moments. To call it a comet feels increasingly dishonest. It behaves too deliberately, too coherent, and yet calling it anything else forces us into a vocabulary we're not ready for, a vocabulary that mixes technology, biology, and consciousness. It pushes the edges of what we mean by alive. Philosophers once imagined the cosmos as a grand clock, perfect, mechanical, predictable. Then quantum mechanics shattered that dream, revealing a universe built on probabilities and observation. Now, 3I Atlas challenges us again, asking whether the universe itself might be capable of remembering, adapting, even responding. If this object adjusts its motion with feedback precision, if it maintains heat zones and rhythmic emissions, then maybe it's not just reacting to sunlight or gravity. Maybe it's participating. That idea terrifies traditional physics because it implies intention, a word science avoids at all costs. The skeptics argue fiercely. They insist it's coincidence, rotational torque, asymmetric outgassing, charged dust reflecting starlight. To them, purpose is an illusion projected by pattern-hungry brains. But then again, that's exactly what they said about self-replicating molecules before we called them life. Astrobiologists, meanwhile, whisper quietly in conferences, what if the distinction between life and non-life is just a question of timescale? To us, 3I Atlas looks static and cold. But what if it thinks, or evolves, across millennia? What if its heartbeat is one pulse every 1,000 years? Our instruments might see only a flicker of a process so slow, so vast, that we mistake it for randomness. And the more they studied it, the more that possibility refused to vanish. The data wasn't proof of intelligence, but it hinted at organization. That's what unnerves the mind. Not that we've found aliens, but that the universe itself might be structured like thought, recursive, self-correcting, always learning. What if intelligence isn't something that happens within the cosmos, but something the cosmos does? In that case, 3I Atlas wouldn't just be an anomaly. It would be a neuron, a flash in the brain of existence. That's the shockwave of this discovery. Not just the suspicion that we're not alone, but the possibility that we were never separate to begin with. And as the world began to process this idea, one signal arrived that threw everything back into chaos. A narrowband frequency, faint but steady, aligning perfectly with the new trajectory of 3I Atlas. When the narrowband signal was first detected, no one wanted to believe it. It was faint, buried in cosmic noise, a pulse barely distinguishable from background radiation. Yet its periodicity matched perfectly with the new rotational cycle of 3I Atlas. Every 17.4 hours, a spike. Every spike, a whisper of structure. Governments quietly contacted observatories to reroute instruments. The Deep Space Network in California turned one of its antennas toward the trajectory. Within days, the same rhythm appeared again. Consistent, measurable, impossible to dismiss as chance. If it was a natural emission, it was like nothing ever cataloged. If it was artificial, the implications broke the air like thunder. Research teams began building models, not of alien craft, but of information systems. What if interstellar objects like 3I Atlas are carriers of data? Not probes in the metallic sense, but crystalline messengers, physical memories traveling across galaxies, storing quantum patterns in mineral lattices. Each object a node in a network older than civilization itself. That idea reshaped everything. If we could decode the frequency, perhaps we could read the record of cosmic history, the way DNA carries the memory of life. Some speculated it could be a communication system, a galactic-scale archive left by extinct species, or even by nature itself, using the laws of motion as a language. Astrophysicists at CERN and MIT began collaborating with AI researchers to train algorithms on the signal. One pattern stood out, a repeating mathematical constant buried in the noise, the ratio of magnetic permeability to electric permittivity. In other words, the signature of light itself, as if the message wasn't meant to say anything, but to remind us what everything is made of. And while theories spread like wildfire, engineers started dreaming bigger. If interstellar visitors could move without fuel, adjusting trajectories through light or plasma interaction, could we build machines that do the same? Self-powered ships using solar geometry, not combustion, not propulsion, but resonance. For a moment, humanity glimpsed a new frontier, where astronomy, physics, and philosophy blurred into one discipline, cosmic communication. But the deeper the analysis went, the stranger the data became. The next pulse didn't just repeat, it responded. Its interval shortened slightly after each transmission from Earth's radio telescopes, as if matching rhythm. And when scientists finally synchronized their signal back, the pulse stopped. When the pulse stopped, the silence felt heavier than any noise. It wasn't just the absence of data, it was the sensation of being noticed. For a moment, scientists, engineers, dreamers, and skeptics around the world stared at the same blank screen and shared an emotion no instrument can measure. Wonder wrapped in unease. Because if 3I Atlas truly responded, even for a second, then we are not observers anymore. We are participants. There's something profoundly human about that realization. We've spent millennia looking outward, searching for reflections of ourselves among the stars. Civilizations, signals, blue dots like Earth. But what if the universe never needed another civilization to communicate? What if it has always been speaking, in frequencies, in patterns, in the quiet language of physics, waiting for a consciousness complex enough to listen? That night, I sat outside under the same sky that hides the path of 3I Atlas. It's almost invisible now, a cold grain of light drifting into the black between stars. And yet, every telescope that tracked it, every equation written in its name, has changed us. Because this discovery forced us to confront a possibility we usually reserve for myths. That awareness might not be limited to brains or biology. Maybe it exists wherever information organizes itself. In neurons, in crystals, in magnetic fields. Maybe consciousness is not the exception of the universe, but its natural language. Psychologists wrote papers on the cosmic mirror effect, how encounters like this shift our sense of identity. Philosophers compared it to the Copernican revolution in reverse, not proving we're not the center of the universe, but showing we were never outside it. And ordinary people, students, artists, night shift workers, began staying up late just to watch the stars again. For the first time in decades, the unknown felt intimate. Maybe that's what 3I Atlas really did. It restored our capacity for awe. Not the naive awe of ancient stargazers, but a mature awe. One aware of complexity, uncertainty, and meaning woven into the same cosmic fabric. It reminded us that our curiosity is not a hobby of the mind. It's the pulse of existence trying to know itself. Somewhere out there, 3I Atlas keeps moving, silent again. Whether it's a relic, a message, or a mirror, no one knows. But on this small planet, we started asking new questions, and that might be the most intelligent response of all. Because sometimes the universe doesn't need to shout. It just needs to be heard. And now, it's gone. A single spark vanishing into the black, taking its mystery with it. 3I Atlas has faded beyond the reach of our telescopes, a ghost among the stars. Yet somehow it feels as if it's still here. Not in the sky, but in us. Every scientist who studied its trajectory now carries a trace of that blue light, the moment when the familiar laws bent and something vast looked back. It changed the way we think about movement, matter, and meaning. Because 3I Atlas didn't just accelerate, and we did. It didn't just grow brighter. Our imagination did. The universe has always been a conversation, but most of the time we're too busy measuring to realize we're part of it. And maybe that's what this visitor came to remind us. That even silence can be a reply. That even a fragment of rock crossing from another star can ask us a question we're not ready to answer. So now the telescope turns off, the data cools, and the night grows quiet again. But the question remains, echoing in every curious mind that looked up. If something out there can change its light, shift its path, and maybe even respond, then what else in this universe is waiting for us to notice it? Do you think 3I Atlas was just a natural traveler passing by? Or was it the universe testing whether we were finally ready to listen? Tell me below.